Welcome to Introduction to Engineering Design, and today we're going to deal with some more mates, combining parts in an assembly. So what I've got is I've got three pieces open here. Down in my lower left-hand corner, you'll see I've got a tube, a rod, and a flat. So what I'm going to do is make a new assembly, and I'll do it from this little paper tab looking thing, and it's going to say make an assembly from a part. So the first thing I want to insert is I want to insert my flat, and I'm going to put it at the origin by using the check mark. Then I'm going to insert the other two components, which are my rod and my tube, and I'm just going to drop these within my drawing. There is my rod, here's my tube. So as you can see, my flat does not move, and I can free drag around my rod, my tube, no problem at all. Okay, so let's look at a couple of mates. You'll see on this rod, I've added a little square end. Two reasons. One is so you can see it rotate, and the second is so that you can have a flat surface to mate. So we're familiar with mates. Clicking the mate icon, and I've got the face of the rod selected, and I'm going to do a coincident mate. I want to mate it with the face of flat one. So if I accept that mate and close out and get this out of the way, you'll see that I'm coincident with those planes. You'll say, well, it doesn't look very coincident. But the reality is I'm right on that plane the whole time, and right there I'm moving forward and aft of it. So I've constrained basically 1 degree of rotation and 1 degree of translation. That translation is actually in the Y axis. So any mate that you have, you can come back and select it out of the tree and right click on it, and I can either go in and edit the feature, or I can actually flip it right here. That's kind of a neat thing. If I edit it, you'll see a command bar comes up right here under my cursor. It gives me a little more control, but that flip is essentially the same thing as this button. So I can flip it so the faces are aligned or the faces are opposing. And that is essentially what a face-to-face mate looks like. So also, if I have a mate that I don't like within my assembly, I could either suppress it or I can delete it. So let me actually suppress this, and you'll see the effect. It goes gray, and then my drawing behaves as if that mate never existed. Now that's a little safer option than deleting the mate. It's a little less permanent in case you decide later on that you wanted it. So back out, let's look at another mate here, and this one is actually going to be a vertex to vertex mate. So we'll click on mate again, except this time I'm going to zoom way on this little square, and I'm going to pick the edge, which is the edge formed by where these 3 lines reach a vertex. And I accidentally selected the face, so let me come back here and pick that vertex. So you see the vertex 1 of the rod, and I want to mate that to the vertex on my flat. There's my mate. I could do an offset distance on this, and I could also lock the two components together, but right now it's a coincident mate. I'm going to go ahead and allow that one to take place. Now look at this very closely, and you'll see that it's quite different than a flat to a flat, or a face to a face. And you'll see that I'm literally just hanging by a thread there, that point. So that has some applications. You'll just have to see where you can use it in a drawing, but that is a vertex-vertex mate. So let's go back and get out of this, and I'm going to go ahead and suppress this one and move that away. So I've suppressed that mate. Now let's look at one other one. Let's look at a tangential mate, and we'll use this piece right here. And let's move my blue out of the way, and I want to do a mate. Except this time I want to pick a tangent mate. So what I'm going to do is choose the surface. First surface is the face of my flat, and the second surface is going to be the outside edge of my red cylinder. Now you can see that mate, once again, it kind of looks like you're going past it, but you really aren't. You're right on the surface there, and you can plainly see that when you go to that view right there. that you stay in plane with it as you move it back and forth. Now, other thing, you'll notice that I put that text on there specifically so I could show you that, yeah, this thing still rolls, it rotates, very much so, even though it's tangential. Okay, so that's kind of an interesting mate. Let's look at another one. Let's combine a mate now, a second mate with this. Let's go ahead and go for a coincident mate on a face of our cylinder and a face of our flat. We'll accept that mate, and now we've changed it a little bit. Now you'll notice when I go to an offset view, I can't really move that back and forth this way. So I stay on the surface, and I can't go past that edge. It still rotates fine, interestingly enough. Let's do one more mate here. Let's go ahead and put a concentric. So I want to put the blue bar, or the blue rod, inside of the red cylinder. So to do that, I'm going to click a concentric mate here, and let me clear my selection out. So let me go mate, and I'm going to go with a concentric mate, and I'm going to choose the shaft body, and I want to put it inside of the extruded hole. Now let's look at how we can flip the direction of this. This is a little bit interesting. So you see I can flip ends on where I'm lining up. Now that just kind of flips which end is in. You'll notice though, if I accept either one, my rod still slides in and out of that position quite easily. You'll also notice that I can spin this. So I can spin that rod as it slides in and out, and I can spin my cylinder as well. So let's apply one more mate. Let's make this edge flush with my end. So I've just made those two coincident. So I've made the rod coincident with the cylinder. And now you'll see that I still have rotational movement within my cylinder. I can still grab that. I still have rotational movement of my cylinder on the surface. So let's look at one other one. What I just did there was I just locked the rotational movement of the red cylinder onto, and I locked it in place. So I locked the red cylinder onto my flat in position. That's just another interesting thing you can do, and I've retained this ability to spin this inside shaft. So those are a few different options, and it's fairly simple mates, but we've gone through what a coincident looks like, what a tangent, concentric, and the lock look like. So that's it for this session of looking at mates within an assembly in Solidworks for Introduction to Engineering Design, Unit 4.1, Puzzle Cube. This is our first assembly introduction. Thanks.